Hi everyone, welcome to Espressif DevCon 2024. Our topic for presentation is what's new in Espressif IDE and debugging essentials. For the next 30 minutes, we will take you through the giving an introduction to the Espressif IDE, and we will talk about some of the new updates and new features which we introduced in Espressif IDE 3.0. And we'll also introduce about the different debugging methods which are available in the Espressif IDE, and then we'll give you a quick demo on those different methods, and then we'll take the Q&A. All right, so this is quickly about us. Myself, Kondal Kolipaka, software manager at Espressif Systems, mainly working on the IDEs. I contributed a lot for the last couple of years to the Eclipse plugins, and recently looking at the VS Code as well. And along with me, we have Ali Azam Rana, is a software engineer for the Espressif IDE. So yeah. So what is Espressif IDE? So this is a customized IDE based on the Eclipse CDT. This is specifically designed to build an applications for the Espressif chips using the ESP-IDF. So earlier we were using the Eclipse plugins. If somebody is using the Eclipse plugin, so the user has to install the Eclipse plugin on top of the Eclipse CDT, and they need to manage some other plugins to get started if they are building an application with the ESP-IDF. Now, with an Espressif IDE, we bundle all the plugins, the Eclipse IDF plugins along with the Eclipse CDT, and also some of the CMake plugins, which will be helpful if you are making any changes in the CMake list file. So this Espressif IDE supports with the 4.0 and higher versions if you're working with the CMake projects. And this also supports all the chips, ESP32 and ESP32S, and the C and H boards. And this works on all the operating systems. And yeah, so it's been quite some time. So we haven't released the major version. So 3.0 is the major release, which we introduced some of the major changes in it. So let me take you through those. The first major change is LSP C++ editor. LSP is the language server protocol. So as we were having certain challenges, if you're working with the existing C++ editor, because of the new language grammar which is used by ESP-IDF, so users having a challenge with the resolving the headers and the indexes. Hence, we thought of moving to the LSP-based editor, and this is built using the Eclipse CDT LSP. So Eclipse CDT LSP is the plugin itself, and we are trying to bundle those plugins along with the Espressif IDE. Hence, it works seamlessly when you're working with the ESP-IDF. So this is powered with the LLVM, LLVM ClangD. The ClangD is the language server protocol, so which basically help us for using any editor kind of features, the code completion, or any IntelliSense or indexing. These things we could make use from the ClangD. So from the diagram, you can quickly understand that. So the ESP-IDF and the Espressif IDE will talk to each other using the language server protocol. So if somebody is using the ESP-IDF 5.1 and higher, we'll be installing the ESP Clang tool as well. So that is already having the ClangD server. So the ClangD or ESP Clang is the fork of the LLVM project, which is an open source. So what we did was we have built our plugin on top of the Eclipse CDT LSP, and that is capable of configuring some of the default settings. For example, the ClangD server. When you switch between the different targets, we will take care of switching the different configuration and stuff like that. And why are we moving to the LSP C++ editor? So as I mentioned, this is majorly resolve some of the header and indexer issues with the existing C++ editor. And ESP-IDF 5.0 uses C++20 and 5.2 uses C++23. And these are something which were not there with an existing C++ editor. Hence, we have to move to the new editor. So other important thing which I wanted to highlight here is, though we use the ClangD editor for editor capabilities, for indexing, header resolving these things, but by default, we still build the projects with the GCC toolchain. So if some users, if they wanted to build with the ESP Clang as a Clang toolchain, So there are some instructions written in the docs Espressif, but though it is an experimental feature, so if you guys wanted to try out, probably like it's available in the docs Espressif. And the other LSP editor features, it includes the first thing being the identifying the language grammars. So if we really look at these editor features, this is nothing new for an existing, compared with an existing C editor, but it offers the other new language grammar and the errors and warnings. These are the some standard editor features which are completely available in the C++ editor as well. For example, the errors and the warning and finding the auto fixes, navigating to the function definitions and declarations, pouring out the function, showing the description for that particular function. And this also offered the formatting using the clang format file. And LSP C++ editor is based on the Eclipse standard text editors. And so if the user wants to make any color changes for the code or the editor, so this can be achievable using the Eclipse text editor preferences. And other important thing which we did as part of the ESP-IDF manager's view is installing the multiple. So earlier, I mean, when I was talking to multiple customers and users, they have a requirement for managing the multiple ESP-IDF versions. So we have built this feature within the IDE itself. Without leaving the IDE, they should be able to add multiple ESP-IDF versions within within the Espressif IDE, and they can able to switch between them by just clicking of a button. And they can also update the ESP-IDF. If someone is making use of a master branch, they should be able to update it to the latest. And we also offer cleaning up those existing versions, for example, remove and remove all. So we should be able to remove the specific ESP-IDF version which is configured in the IDE. Other improvements includes bundling the Java 17 with the Espressif IDE. So by default, we bundle the Java 17 with the IDE now. So earlier, the users has to install the Java 17 specifically in the system. Now, if somebody is using the Espressif IDE, by default, Java 17 is bundled across all the platforms. We are also creating the default OpenOCD debug configuration for a new project. So this has to be done earlier. A lot of configuration has to be done. Now, if you are creating a new project, we create this default debug configuration by default. And we also done a couple of improvements on the launch configuration. For example, when you switch between run to debug or debug to run, so we auto choose the respective configuration so that you can just click of a button, you should be able to build a project. And we also added the support for Eclipse 03. Currently, we are working on the 06 support. Probably it will be available in the next release of an Eclipse Espressif IDE. And other improvement is the SBOM tool integration, which was already there in the ESP-IDF. Now that something is integrated within the Eclipse, now we should be able to generate the SPDX file for your components and the projects within the Eclipse, and then use this file as the SPDX file for checking the vulnerabilities. All right, so before we get into the debugging methods, I would like to quickly take you through the demo of these features. So here is an Espressif IDE. So the first thing which I would like to talk about is the ESP-IDF Manager. So this ESP-IDF Manager menu is available from the Espressif menu. Click on ESP-IDF Manager. So this will launch the ESP-IDF Manager view. So if you already added any ESP-IDF versions, it will show here. And there is a button right side, so you can add ESP-IDF. And here you will have two options, whether I could choose an existing ESP-IDF or I could also download the new one. So for the demo, let me choose an existing one, use an existing ESP-IDF directory. So let me choose ESP-IDF 5.2.1 and click Finish. So once the installation is done and the required tools will be installed here, the tools installation is done, and the Eclipse will take care of setting up the required CMake toolchain files and the core build toolchains. Now I can switch between them. For example, if I wanted to switch from the 5.3 version to the 5.2, I can just click on this radio button and it will switch to this. And then I should be able to go and build the project with the 5.2. So that's about the ESP-IDF Manager's view. And the other thing which I wanted to show you is the LSP-based editor. So yeah, so this is a simple Hello World project which I opened. As you could see this, if you compare with an existing C editor, the color codes and everything looks a bit different. So this shows that this is the new editor. So by default, if somebody is working with the 3.0, by default we will open only with the LSP based editor. So there's no way user could make use of the existing the old C++ editor. Though if you're working with another projects, not the ESP-IDF, but yeah, there is a way you could open. But if you're working with the ESP-IDF projects, this is the only editor which is available now. I think that should be sufficient because it is able to support the new ESP-IDF and all the boards as well. And this editor, like for example, if you wanted to see the hover function, as you could see, it shows the documentation for it. And click of a button, you should be able to navigate to the function definitions. And yeah, I could keep navigating to the different functions. So this was a big challenge earlier because to implement this functionality, there are a lot of settings has to go in place. But now with the LSP, this is like the very simple thing we could able to achieve the function definition and navigation. And yeah, so it also supports all other features like a code completion, any other standard editor feature which you are looking for. Other important thing which I just wanted to mention here is, so this as the all the settings were done in the preferences page. So as an end user, absolutely we need not to make any changes, but just I'm referring here if you go something wrong. So this is the place where you can go and check whether it is trying to build with the right tool chain or not. As we are building with the GCC, we need to specifically mention the drivers path here, and because otherwise you might see some errors. And the other required configuration is done in the .clangd file. So this is the compilation database. For example, if you're dealing with the custom build directory, so this is something we will auto update. And some of these flags, as we are trying to build the project with the GCC, but for the editor we are using the clangd, hence we need to remove certain flags, and these challenges are documented in our docs. I think that's pretty much which I would like to show. Yeah, thank you, guys. Maybe I will hand over to Holly to take it forward for the next rest of the presentation. Over to Holly.
Thanks, Kunal, for the presentation. I'll just walk you through some of the basic debugging essentials in the IDE and the features that we are offering. So let's see what we have here. So like basically, if you can see in terms of embedded, you can divide the debugging into two major things like postmortem and the live debugging. And the Espressif IDE will offer you like the GDB stub debugging option and the codem debugging, and also will allow you to do live debugging with GDB and OpenOCD. Let's dive a bit deeper into what these are. So basically, GDB stub debugging, how it works is that the chip in itself has a panic handler, and if that you have enabled the GDB stub on any panic behavior, what it will try to do is like create a snapshot of the system and initialize a GDB stub on a device, and then that will communicate with your computer via UART. And the Eclipse plugin or the Espressif IDE comes in a way that like there's a GDB event that is posted on the serial monitor, and when that event is posted, it will create a GDB connection with the device and will let you analyze all the things that have gone wrong after in the postmortem. And basically, it will let you interact with the chip in the panic mode. So if you see, like, it is kind of a live application, but the execution is halted. You will be able to view the stack trace, registers, and some basic overview to figure out what went wrong. And it communicates with the serial port, and it's pretty easy to set up in the IDE. Like you can simply enable it with the SDK configuration handler, and the IDE will automatically launch the debug mode in case of a panic. And moving on to the core dump, also another essential tool for the post-mortem analysis. The difference between this and the GDB stub is that here the core dump is either saved in the RAM on the device by the panic handler, or it's output via UART, depending on what configuration you have enabled through the SDK config. And similarly, the Eclipse plugin will listen to the core dump event via the serial monitor that you have attached to the device. And whenever that happens, it will fetch the core dump file and analyze it through ESP core dump IDE, and then attach the debugger to that particular core dump file. So basically, you are not attaching the debugger to the device itself, but to the dump file that you have extracted from it. And it can be beneficial in case like you don't have the device at hand, but like you can get the dump files and analyze them later in the IDE. Similarly, it's a very simple configuration through the SDK configuration editor. Like just to mention one important thing is like there is no continuation either in core dump or GDB stub debugging, because both of these are post-mortem. So basically, you need to restart the execution. In case of core dump, if you are analyzing a dump file that is already present on your disk, it could be that the execution is already continuing in the background. But with GDB stub debugging, you need to make sure that you restart the execution, because the execution is halted and cannot continue further. Moving on to the live debugging section, the OpenOCD debugging. You can either use the ESP proc board or the built-in JTAG, depending upon the device or the kit you are using. And the IDE will itself create a default debug configuration and take care of starting the OpenOCD server and GDB client, and will connect over the JTAG. You can set the breakpoints and view variables, memory, and register live, and all the debugging things that you can expect while the application is running live are present to you. So let's quickly go towards the demo. Okay, so here I have a basic Hello World example, and let's first view how the live debugging will work. And if you will create a project in the IDE, you will have two basic configurations: a simple Hello World configuration and a debug configuration. And you need to make sure that you have selected debug here. Just to quickly go into what we get with the configuration. In the debugger tab, you will have some important parameters that you'll need to consider based on the target you are using and the board. Like these are essential, and you need to configure them properly for OpenOCD to start and connect to the device. Other than this, some common errors regarding OpenOCD getting timed out are also very common. So if you move towards the preferences and the Espressif tab, you can configure the GDB server launch timeout to more than 25 seconds, which is the default value, to something more in case you are getting some timeout errors. Once this is done, you just need to simply have the device plugged in and click on launch debug. The IDE will just compile anything if there are some changes to the code, and we'll try to connect to the debugger. Yeah, so you can see on the left side, you have all the threads or the stack trace that is available on the device at the moment. And the execution will halt on the very first line for the main function. You can set your breakpoints. On the IDE, simply continue the execution to the next step, and you'll see it will stop there. On the right, you will have all the variables available to you in the current stack, and you'll be able to view them. The other important thing, like you have the registers view. So you get like a basic overview of the registers as well. All the values are present there. Moving on further towards the peripherals. Yeah, so the SVD file for each chip is like supplied with the IDE itself. So you are able to view all the peripherals that are available to you on that particular chip. So yeah, that's basic overview of what the live debugging will look like. So if you continue this further, you have the option to step over. Okay. You can see the values are getting updated in the real time on the device that is connected. So let's move further. Yeah, another thing is like you can simply step into a function and you'll see that it will jump right into the source file where it's getting the function, and you can go further. So this is pretty much for the live debugging. Now let's move towards the postmortem analysis. Okay, now let's move on towards the GDB stub debugging example. What I've done here is simply added a panic point in the hello world example after 3 seconds. And to enable the GDB stub, you simply go open the SDK configurations, go to the GDB stub, and you need to make sure that GDB stub at runtime is enabled. And if you want like FreeRTOS tasks to be listed through GDB stub, like to properly show in the stack trace and the threads, make sure to check this as well. And verify that it enables this option as well, GDB stub on panic in ESP system settings. So once that is done, what we will simply do is, my project is flashed on the device. What I will simply do is like connect the serial monitor to the running device, and you will see how it pops up with a message and lets you switch to the debug perspective. So it will ask you that a GDB stub event has occurred, and it may switch to this. So if you want, you can press yes, we do. So let's see. Give it a while to connect to the device. Yeah, so as you can see that we get switched over to the debug perspective in the Eclipse, and you are on the left side, you have all your threads that are suspended. So if we go back to our app main, we can see that this is where the panic happened, and we have the like variables available to you as well. And if we go to the registers, you can also view the value in different registers at the time the panic happened. So as stated before in the presentation, this is a crashed device and you cannot continue the debugging here. So the only possible thing to do here is to like say, okay, let's stop the debugging. This can let you like diagnose issues that happen during the runtime and give you a proper picture of like, okay, this is where the crash happened, and you immediately get switched to this debug perspective to analyze the failures. Moving on from this one, let's stop this and go back to the window. I'll just simply close this project now to go towards the core dump example. But we don't want that. And here, the hello world example. We have the similar thing as to the previous example. We are simply just adding a panic in our loop. And if I go to the SDK configuration settings to show you how to actually configure this, there is an option for specifically core dump debugging, and we need to enable it and set it to UART data destination. So we keep connecting our serial monitor, and it detects that the core dump event has occurred and fetches and analyzes the core file and lets you debug it or view different aspects of the application when it got crashed. So going back over here, let's see, we need to flash this. Okay, this is fine. Quickly flash this to the device. So now this is done. Let's switch to the terminal, connect the terminal, given project, given COM port. Okay. So as you can see right around here, we have this failure. Similarly, like GDB stub, the core dump event when occurs, the IDE will ask you that if you want to switch to the debug perspective. Yes, we do. Give it a few seconds to fetch everything, and then it will switch to the debug perspective to let you analyze. Okay, so as you can see, similar kind of behavior as GDB stub, and we have like all the stack traces here, right? So you can view all the different threads which got suspended when the panic occurs. Going back to our main file where this happens, you can see similar the different variables and their values. And this is actually not directly now connected to the device. It actually fetched the dump file and now displaying it in the debugger. And similarly, you have access to variables that are available in the current thread stack. So if I switch to a different one, these variables section will also get updated. And you can backtrace or analyze your issue of crash. So yeah, thank you very much for listening. That's all for the demo.